with you when we're done.
Yeah, of course.
Okay, so let's go ahead and first take a look at your progress report. I've just shared my screen with you, so let me know if that kicks in. Can you see my screen?
Not yet. Hmm.
You should be able to see it now.
Oh yeah, it's loading now. Okay.
Got it?
Now. Yep.
All right, so this is your progress report. So your target completion at this time is 48%, but you've actually completed 57 or 50%. Um, so you are just a tiny bit ahead of target,
Okay.
which is why your overall grade and your actual grade are exactly the same. You have 83%.
Mm-hmm.
Now, one thing I do want to let you know is that if you would like, you can go back and redo some assignments over the Thanksgiving break to boost up your grade if you would like.
As much as I would really love to get ahead and everything, my mom is actually not letting me do any
Oh, okay.
schoolwork
That's
over the
fine
break.
too. That's fine too. It's just an option. As long, whenever you're ahead, if you want to go back and redo any assignments, you can. So
Okay.
please keep that in mind.
Thank you.
Okay, so you had some questions on conditional probability. Is that right?
Yes.
All right, so let's look and see what's going on. We're going to go over the assignment, and like I said, I'm going to go ahead and record this. And then once we go over the assignment, this will hopefully give you an opportunity to ask some questions, that kind of thing.
Okay.
Okay? All right. Let me cancel that for a second. Open. All right, so this is our first actual problem. And what this is saying here is it's just asking you if you understand what the concept is of conditional probability. So it says the conditional probability formula is P of X, and this bar is actually written as given as the word given. So what's the probability of X given that Y does happen?
Okay.
Um, so the formula is that you look at the probability of X and Y, and that's what this intersection symbol means. That's the probability of X and Y divided by the given probability, which is Y. So if you were to say that in words, what you would be saying is, what's the probability that both things are happening over the probability of the given?
Okay.
Now, the reason I like to put it in words as well is sometimes when you're looking at word problems, they use the word given whenever there's conditional probability. Does that make sense?
Yes.
Okay, so this next one says the conditional probability of D given N and the probability of N given D are equal. That is not true.
Mm-hmm.
Division is not commutative, therefore it does matter what you're dividing by.
Mm-hmm.
Does that make sense?
Yes.
Okay. The notation P given S indicates the probability of the event R given that the probability of event has already happened, and that is true. That's why we read it as the probability of R given S.
Yeah.
Okay. The next one is not true. It says that the probability applies only to independent events. That is not true.
Mm.
Conditional probability works when you have dependent events. Dependent events mean that, for example, conditional probability would be something like, you pull three marbles out. What's the probability that the third marble's blue given that the second marble was yellow? You know what I mean? Like
Yeah.
That's conditional. So they're dependent on one another. Now, the last statement is true. It says conditional probability can be calculated using Venn diagrams. Now, the reason this is true is because when you look at the Venn diagram, if you have X and Y here, this is where they overlap. So that's the probability that where they overlap. So that's always easy to do when you're looking at a Venn diagram.
Okay. Yeah, the visual always helped me more.
Yeah.
Out.
So does that make sense, hun?
Yes.
Okay. Let's go ahead and look and see what the next question was asking. Okay, so here's an example where they are actually using, let me see if I can open this other screen a little bit more because I seem to be missing just like a tad of the question each time. There we go. I can't write on their PowerPoints, so I just have to screenshot them and then I can write on them. Okay, so this is just some statistics. This 9 in here is the probability of both things happening. Does that make sense?
Yeah.
Okay. And then this circle here is the probability of people who are in band. This is the people who are in track. And then these are the people who take both band and track.
Yeah.
Make sense?
Yes.
All right. So this says, given that a randomly chosen person participates in band, so that's the given, what is the probability that the student also participates in track? So what we're looking at here is what's the probability somebody's in band and track divided by the probability that they're in band.
Okay.
So there are 9 people in both band and track out of, and then you've got to look at the whole circle for band. So there are 33 people in band.
Okay. Yeah, I was thinking I had to add all the students together with that one or something.
No, this one is a given, so it's only given who's in band.
Okay.
Is that good?
Yes.
Any questions?
No, that one makes more sense now.
Okay, and do you see how I kind of wrote the formula off here to the side also, just to remind myself where those numbers should go?
Yeah.
Okay,
Yeah.
let's look at the next one. Okay, so on this particular problem, it tells us what the total is. So it tells me I have 154 10th graders at this high school. They were they were polled on whether or not they enjoy algebra or geometry course. The results are below. So in algebra, there were 34 females, 33 males, 40 females, and 47 males. So, what is the probability that a randomly chosen 10th grader is a male? Well, we know that there are a total of 154 students, correct?
Mhm.
And to figure out how many males there are, we would add these two numbers together. So that's where the 80 out of 154. Notice that the word given is not in this at all.
Yeah.
So that's why it's over the total amount.
Oh, okay. So if it has a given, then it's probably one of the
Right.
numbers that are
Yes.
in.
So let's look at the next sentence. It says, find the probability that a randomly selected 10th grader is male, given that the 10th grader prefers geometry. All right, so now we're looking at who's male and prefers geometry over the probability that they are male. So you want to go over here. Male and geometry is 47 students. Now, how that's the given is the probability that they're male. So how many students are male?
That would be 80.
80. I don't know why it says correct.
Yeah.
What is the probability that, yeah, because it should not be 87. It should be 80. I promise. Because it was says given. Oh, wait, no, no, it shouldn't be 80. I'm glad I reread that sentence. The given piece of information is there a 10th grader that prefers geometry. So this should have been prefers geometry down here. So how many people prefer geometry?
That was 87.
That's where the 87 comes from. Sorry about that.
Okay.
Down here, they're asking you to write it. It says, are the events male and geometry independent? No, male does not equal probability of male given.
Mhm.
If you look at the probability of being male, it would have to equal the probability of male given geometry if they were independent, and they're not.
Yeah.
Because the probability of being male was 80 out of 154, and the probability of male given geometry is that.
Yeah.
Good.
Yes.
All right. So, are you feeling a little bit more comfortable?
Yeah, I think it was later on that it started to get like really tricky for me.
Okay. So let's look at this one. This one here says that a dentist polls his patients and find that 83% brush their teeth at least twice a day, 47% floss daily, and 19% brush at least twice a day and floss daily. Okay, so let's go ahead and draw a picture because I find it easier actually to look at the picture. So when you make a Venn diagram, you want to start with what's in the middle. So this is 0.19%, correct, that do both.
Yeah.
So the brushing, let's do B for brushing. That's got to total up to 83%. So if you take, 0.83 minus 0.19, old school, you get 0.63 goes in this box here because the whole circle together has to add up to 83.
Okay.
Then here it says 47% floss daily. So we got to subtract that 19 from there. So this would be 0.28, right?
Yes.
All right, so then it says, what is the probability that a patient flosses daily? This is the flosses daily given that he or she brushes twice a day. So remember that's the probability that they both brush and floss, which we know is 0.19, over, and it's saying what is the probability, the given that they brush at least twice a day. So the probability that they brush twice a day is this whole thing, which is 0.83.
And then you just divide that to get the percentage.
Yes.
Okay.
And you should get like 0.2289, right?
And then you'd round up to 23. Okay.
Correct. So that's where that 23 comes from.
Okay.
All right. So our next one. Okay, so the next problem says that a box contains 4 red balls and 8 black balls. 2 balls are randomly drawn, blah, 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 and are not replaced. When you don't replace something, that makes it dependent.
Okay.
Okay, so are not replaced means that it is dependent.
Okay.
Okay? So it says let B be choosing the black ball first and event R be choosing a red ball second. So to get a black ball first, that's 8 out of 12 because there are 8 out of
Mhm.
12 total. The next one says give a red ball given the probability that you got a black ball.
Mhm.
So there out of the red balls, there are four, right? Red
Mhm.
ball. How many red balls are there? Yeah, four red balls, but there's only 11 balls left. So that's 4 out of 11.
Okay.
The last, are you okay with that? Do you understand why there's only 11 balls left?
Yeah, because it's not replaced.
Correct. The next one says, what is the probability of getting a black and a red ball? So you would take 8 over 12 times 4 over 11.
Okay.
Now you can either reduce here, which makes it a little easier. This is 1 and this is 3. So that gives you 8 out of 33.
Oh, okay. Yeah, I don't think I simplified that before.
That's okay. You
Yeah.
might have thought it was 32 over whatever 12 times 11 is.
Yeah.
132. In which case that does reduce.
Mhm.
The next question says the probability of the first ball chosen is black and the second ball chosen is red. So the first ball being black means that you have an 8 out of 12 chance that the first ball is black.
Mhm.
Correct? Now we only have 11 balls left, so that's 4. So
Mhm.
that doesn't change. That just gives you, wait, it says the probability of first ball chosen is black, the second ball chosen is red, is about. So that's your 32 over 132, but they want you to change it to a percent. So what do you have to do?
Okay, so then you'd have to divide that.
Right. And so it's approximately 24%.
Yes. Okay.
Okay. So then these will start to get kind of like, you know,
Yeah. This one I went back and I never could figure it out.
okay. So it says at a hospital, 56% of the babies born are boys. Of the baby girls born, 12% are premature. What is the probability of a premature baby girl being born at this hospital? Um, well, if there's a 56% chance that it's a boy, then there's a 44% chance that it's a girl.
Mhm.
What is the probability of a premature baby girl being born at this hospital? So, and let me just check something here. Yeah. So what we're looking at is so do you understand, first of all, how I got the 44%?
Yes.
So what's the probability of having a girl and being premature? And that is 0.44 times 0.12.
Oh, okay. I was doing 12 divided by 44.
The word and in mathematics means to multiply. Does that make sense?
Yes. So then just multiplying those two would give.
Right, exactly. All right, so next it says at Zanger's Autos, 3 out of 5 cars brought to the service need oil. Of the cars that need an oil change, 4 of every 7 also need tire rotations.
Mhm.
What is the probability that a car comes to the garage needing both an oil change and a tire rotation? So what's the probability they need an oil change?
Hmm. 3 out of 5.
3 out of 5. Okay. And means to
Multiply.
multiply the probability that they need a tire rotation.
Okay, and that's 4 out of 7.
So that equals 12 out of 35.
Okay. Oh, okay.
Oh, wait. This was a 5. I wrote that wrong. 3. That's 12 out of 35.
Mm-hmm.
So again, the key here is that word and.
Okay. Yeah, I think I kept dividing things.
Okay, Elijah writes the numbers 1 through 20 on a separate sheet of paper. There are 16 white slips of paper and 4 yellow slips of paper. There are 8 odd numbers on the white slips, and the rest of the odd numbers are on yellow slips. Are the events odd? What are the events odd and yellow independent? Okay. I was like, what? And okay, so the answer here is yes. Because if you look at the probability of choosing an odd number, uh, the number of, there's 1/2, so there's 10 out of 20 numbers are odd. So 1/2 of them are odd.
Okay.
And if you look at the probability of an odd number on the yellow sheet of paper, well, there are 2 out of the 4 yellow sheets of paper are odd. So the answer is yes, they are independent because those conditions are equal to each other.
Half and half.
Right. There are 10 odd numbers out of 20. So that's what's the probability of odd. And odd and yellow paper, or given that it's on yellow paper, there are 2 odd numbers on the 4 pieces of yellow paper.
Okay.
So since those 2 values are the same, that means that they are independent events.
Okay.
All right, here's our last one. This is another one of those Venn diagrams.
Mm-hmm.
So this Venn diagram says which conditional probabilities are correct. This says the probability of D given F. So D and F together. So here's D and here's F. So there's 6 on top, right? And then
Right.
how many are in F total? There are 34 in F total.
Okay.
So this one is correct. Here it says probability of E given D. So E and D. So here's E and D are right here. So that's 7. And then given D, and D has a total of 25 in it. So that one's also correct.
Mm-hmm. Okay.
D given E. Now there are 7, right? But because the given is E, E is this circle here, which only has 18. So this would have been 7 over 18.
Okay.
So remember that what's on top is the and, probability of D and E over the probability of the given, which is E.
Okay.
Any other questions, hon, or anything else you want to ask me?
I don't think so. I think a majority of what I was doing was dividing instead of multiplying.
Okay, well, good. I'm glad we were able to, and I appreciate you letting me help you get that cleared up right away before you took the quiz again.
Thank you for that.
So are you and a parent going to join the Skype meeting this evening about the EOC?
Yes.
All right. Well, then I look forward to seeing you, or seeing you virtually at 7 o'clock. Okay.
Thank you.
You're very welcome, hon. Talk to you later. I'll reset that quiz. Well, I don't think I have to. You already have. Do you have another take, or do I need to reset?